This conference will now be recorded.
कैसे हैं? I hope everything well. So how is the life going on? The agenda of today class is to start and continue with alcohols, phenols, ether. It is said that it is one of the most important in chemistry, organic chemistry, because of the fact that the consumption of ethanol determine the growth of lots of industry. Ethanol is one of the alcohol which is used practically everywhere in your daily life. Maybe medicines, maybe the petrol we consume, and thousands more. So, as you know, in any chapter, how do we start? We start first with the nomenclature, all right, and then we discuss certain applications. Then we go ahead with their methods of preparation, and then we discuss the physical property, and lastly, we discuss the chemical properties. But it is going to take a lot of time because it is, as I said, one of the biggest chapter, and the benefit of this chapter is the more comfortable, the more command you will be having in this chapter, that will give you command in whole of the organic chemistry. So that is the application of this chapter. So moving ahead with alcohol, phenols and ethers, beta. The first thing I'm introducing is nomenclature. Alcohols are compound containing hydroxyl group attached to the alkyl group. This is the R, this is the H. So we replace the H and we put the hydroxyl group that give rise to the general formula of alcohols. These are regarded as hydroxy OH, derivative of hydrocarbons and also called aliphatic alcohols. For example, the first member is CH3OH, methyl alcohol. Keep it in mind, this is bitter in taste and highly toxic, can kill a person in few minutes only. Ethyl alcohol, it is again bitter in taste, tolerated to a small extent. The propyl alcohol, undrinkable, all bitter in taste. Interesting thing, just for your reference, presence of one OH in a compound, organic compound, will make it bitter, and presence of more than one OH in one organic compound will make it sweet in taste. Ethylene glycol, glycerol, these are going to be sweet in taste. But remember, everything which is sweet is not to be tasted. For example, this ethylene glycol is highly toxic. 30 ml, that is one international peg, can kill a person. You understand? One OH always bitter, more than one OH always going to be sweet in taste, like sugars we eat. That's the kahani. Go ahead. Alcohols are further classified as monohydric, 1OH, dihydric, 2OH, trihydric, or polyhydric, depending upon how many hydroxyl group. Ethyl alcohol is monohydric, the glycol or ethylene glycol is dihydric, and glycerol is trihydric. All what you are seeing on your screen are going to be extremely important. Apart from these alkyl alcohols which we have discussed, we also have aromatic alcohols known as phenols. Phenols are also bitter in taste and they have a particular smell, distinct smell. These are derivative of aromatic hydrocarbon in which the hydroxyl group is directly attached to the carbon atom of the aromatic ring. You remember benzene has 6 hydrogen attached to each hexagon on this. You replace this hydrogen by OH and we get the phenols are going to be obtained. The phenol, it is also known as carbolic acid. You remember Lifebuoy soap, right? That contains phenol. It is a mild antiseptic. 2-bromophenol. Phenol will be the head of the family and hence it will be called as 2-bromophenol, and this position is known as ortho. This is going to be 2-methylphenol, and beta, this one I'm saying third one is highly important. Keep it in mind, the orthocresol. You might be wondering that you have done nomenclature in class 11th, then why we are repeating the nomenclature? Because if you do not know the name of the compound, you will not learn organic chemistry at all. Because sooner I'm going to write orthocresol react with bromine water. What is going to be the product? If you do not know orthocresol, then how you can proceed? Okay. Orthocresol, you can have metacresol and you can have paracresol depending upon methyl group is on second or third. or fourth with respect to OH. Please, everything I'm talking about is extremely important. You make notes or you do not make notes, that's a secondary thing in nomenclature. But yes, whenever the problem comes, you're going to solve it. So this you can right now skip it. No need of making notes because I'm going to put it on the channel and it will be always available to you people. So, my dear friends, phenol is monohydric, catechol, dihydric, 1,2-dihydroxybenzene. You call it benzene diol. Resorcinol, 1,3, and 1,4 is quinol or hydroquinol. Very important. देखो Guru Mantra, aid to memory, no scientific reason. See, I write 1, 2, 3, 4. These are the position on the benzene ring. So one is this, always this, right? One is this, one is this, one is this. 2 C R Q. C for catechol, R for resorcinol, Q for quinol. That means 1 2 is known as catechol, 1 3 is known as resorcinol, and 1 4 is known as quinol. My dear, you will appreciate when we are going to hit Elb's persulfate reaction that I made you remember in this way. Now this is triol, benzene triol, this is hydroxyquinol, and 1,2,3 trihydroxybenzene is known as pyrogalol, a very important compound. It is used for absorption of oxygen. You know, when I'm making a story, I'm not wasting time. I'm just investing time so that with the help of a story, you are going to remember that. Just for your reference, these are going to be important. I will write copy where I think that you should write. You should write in your rough notebook, catechol, resorcinol, and quinol. Aromatic alcohols. It may be noted if the hydroxy group is not directly linked with benzene ring. Important, not, and is present on alkyl state, then the compound is not a phenol. Phenol में benzene के ऊपर होना चाहिए, then it is going to be known as aromatic alcohol. My dear friends, he has asked, he will ask, what is the difference between phenol and aromatic alcohols? Right? This is a phenol की category में आएगा, whereas this will be aromatic alcohol की category में आएगा. You know the difference? I highlight, this is important. I assure you, you go and ask your friends, they won't be knowing the difference because it resembles aliphatic alcohols in characteristics. Thus, the aromatic alcohol are those in which the hydroxyl group is present on the side chain of the aromatic, which has to be aliphatic chain. That is the aromatic alcohols. Understood? We are going to prepare all of these. So sooner or later, you will be needing all of these in your chemical properties, methods of preparation, and so on. Again, an important classification. Alcohols containing sp3 carbon, मतलब जहां पे OH लगा है, that is going to be the sp3 hybridized carbon atom. See, the carbon which I have highlighted is sp3 carbon. So here, this is going to be known as 1 degree because the carbon to which OH is attached is 1 degree. You also call it primary alcohol. Here the carbon to which the OH is attached apart from sp3, it is 2 degree and hence it is classified as 2 degree alcohol. And here the carbon is 3 degree, you call it tertiary alcohol. Important alcohol. You might be asked very soon, how will you differentiate between 1 degree, 2 degree, 3 degree alcohols? We will be discussing Victor-Meyer test and so on. Remember, sp3 carbon is going to make they behave differently. sp2 different hoga. Allylic alcohol. If next to double bond, the carbon has one OH, those are classified as allylic alcohols. Allylic. Understood? And If you remember, the OH has to be given preference over the double bond. And my dear friends, hence you are going to call 1, you're going to call it 2, and you're going to call it 3. And this is going to be prop 2 in 1 all. I take this opportunity to revise one more thing. See, if you had halogen, right? Then bete, the numbering has to start here. That will be called as 3 bromo, right? Prop, right? You may skip, you may write 1 E. You may skip 1. That is understandable. So halogen, nitro, if they come, they are not going to be given preference. OH is a family. Okay. Similarly, bete, you are going to select the longest chain in compound 2. So this is going to be 1, 2, 3, 4. This is going to be second position we have OH. So you're going to call it but 3 in 2 all. That will be the name of this compound. These are allylic alcohol. And here it is going to be what? 1, 2, 3, 4. That's the same thing. It is going to be only difference here is going to be this. It is going to be 2-methyl kept first, but 3 in 2-ol, and these are classified as allylic alcohol. Allylic is next to the double bond carbon, right? The benzylic alcohol next to the phenylic carbon is, my dear friends, the benzylic alcohol. This is benzyl alcohol. This carbon is known as benzylic. This is very important carbon because if you are going to break OH, that is going to be leading to a very stabilized carbocation. So they will be having entirely their different characteristics. Their properties are going to be different. This is going to be the benzylic carbon, the benzylic carbon. Rest the name you understand. Please focus on this. I'm giving you few seconds. You try the name of this compound, and for a time being, please just mute it. Just pause the screen, solve it, and then you go ahead. In this way, you can make a connectivity. Right. Phenyl ring will be the substituent if the aliphatic chain is present on an aromatic compound like phenol, then it is going to be the major thing aliphatic. 2-phenylethanol. This is going to be 2-phenyl propane 2-ol, the name of the compound. Vinylic alcohol. If the OH group is attached to carbon atom of a carbon-carbon double bond, those are known as vinyl alcohol. These are going to be quite unreactive because of the resonance. This bond will become very strong to break. They will be having a different chemistry. Phenols, we have already discussed. Phenols. Stress, you should know benzylic alcohol, you should know allylic alcohols, and you should know vinylic alcohols. Apart from that, we have proper gylic carbon. See, this carbon is known as proper gylic carbon, and this particular compound will be known as the propyl alcohol. Please notice the difference. This is the double bonded carbon. This is known as beta which? The allylic alcohol, right? Allylic versus propyl. I remember a question from your JE. They asked which of the following is propyl alcohol. So simple reason. We cannot skip it. That's the thing. I'm giving you a little bit of homework also, right? You should try it. You should do that. In that way, we will be saving a bit of time, and but at the same time, revision will be there. So now, beta, do solve it. That is important. Now, if this is the case, right, you have to start in this way. You can write cyclobut in 1-ol. You can skip it entirely, your choice, right? That's similar to that. In IUPAC system, let's talk about the polyhydric or maybe dihydric alcohols also, are named as di for 2, tri for 3. See this. This is ethane 1,2-diol, and this compound is very, very important. This is known as ethylene glycol, or this is also called as glycol in the common language. Just to tell you so that you remember, this compound is sweet. This compound is highly viscous. What do you mean by viscous? It is sticky, like sugar syrup in jalebis we consume. It is viscous, highly viscous. And this is highly toxic, the ethylene glycol. This is also known as a coolant, right? The antifreeze that is present in the radiators of our cars. Propane 1,2-diol. This is propane 1,3-diol, 1,2,3. You can see that is OH. And this molecule, the last, is 1,2,3. Propane 1,2,3-triol. This is known as glycerine, or it is known as glycerol. This compound is sweet. This compound is antiseptic, and this compound is hygroscopic. Hygroscopic means it absorbs moisture. It absorbs moisture, and that is the reason that it is used as in creams, the face creams, the skin creams. It absorbs moisture, keeps our skin hydrated. Antiseptic, it kills the bacteria. And my dear friends, it is not at all toxic. You can drink it if it is pure. And that's the reason it is known, it is used in lots of medicines to make the medicine sweet. Now, Vacho, the nitro has second preference. The OH has first preference. You can watch more nomenclature on the channel Shived. There I have discussed the nomenclature in detail in class 11th. In detail, I have discussed lots of many more things. Right now I'm focused on alcohols OH only. There I'm discussing practically everything. So kindly go and see that. So that will be beneficial. It is of no charge. So you can see that, you can propagate that channel. This is 4-nitrophenol. This is 3-aminophenol. And this is going to be 2,4,6-trinitrophenol. This is picric acid. This is yellow in color. Why I'm writing yellow in color? Because the compound which is formed and is colored, that will be used as a test. And one more interesting thing, presence of more than one NO2 makes the compound explosive. You cannot heat it. So my dear friends, I have discussed 1 degree, 2 degree, 3 degree alcohols. I have discussed phenols. I have discussed aromatic alcohols, right? Aromatic alcohols. I have discussed allylic. I have discussed vinylic. We have discussed propergylic also. We have discussed dihydric and polyhydric alcohols. We have revised in nomenclature. You cannot skip anything, right? I'm going to give you problems right on this platform only. So solve those, because nomenclature is something that will be always be needed. Nomenclature is the language of organic chemistry. You cannot skip it. Isomerism in alcohol. Chain isomers. Alcohol containing 4 or more. 3-pay, you will not discuss chain isomers. Exhibit chain isomers, in which isomers differ in chain of carbon atoms attached to hydroxyl group. For example, here you have a parent chain of 4 carbon atoms, and here you have parent chain of 3 carbon atoms. You cannot include this methyl in the chain, right? You have to include the carbon where OH is present on the chain, and then you have to proceed in the longest chain. That's the way. So the chain length is different. Position is for 3 or more carbon atom. Please notice 4 or more, 3 or more. These are not to be rote learned. These are just to be practiced. This is prop in 1-ol, and this is going to be prop in 2-ol, also known as isopropyl alcohol, IPA. You might have seen a blood technician, whoever draws blood from our body. Maybe you have given blood for some blood testing. He or she is going to wipe our skin with a cotton swab that contains IPA. It is a disinfectant and it clears greases and body oils from the skin. Then he is going to puncture, because in that way the skin is going to be fresh and there's going to be no chance of any infection, any microorganism going in our body. Continent isomerism, we are continent. So that is the third one, functional isomers. Alcohols containing two or more carbon atoms exhibit functional isomerism. One is ethanol and the other is ether. One more, let it be C2H5CH3OH. This is propanol. This is CH3O C2H5. All right. These are functional isomers. Alcohols are functional isomers of ethers. Optical isomers, the alcohols having chiral carbon, as you might say it, are also going to show the optical isomerism. One will be dextro, one will be levorotatory. And you remember, presence of chiral carbon is must for the optical activity. In that way, the compound is going to be indivisible into different compounds. Enough. Let's judge you. Draw all the structure of all isomeric alcohols of molecular formula C5H12O and give their IUPAC name. Classify them as primary, secondary, and tertiary alcohol. My dear friends, I advise you please read the question, pause it, solve it, take 5 minutes, and then you shift to the next screen where you will find all the answers. In that way, it will be better than your offline class because you will be having everything at one place. Please pause for 5 minutes max. That's the maximum time. Now, after pausing, you will be finding all these written on your screen, right? The 1 degree, the 2 degree, the 3 degree have been written. There's one more question taken from your NCERT. Name the following compounds according to the IUPAC system. Rarely he will answer the common system. But when the question comes, he might write the common system name, and then he will be asking you to perform the reactions on that. Otherwise, he will ask the IUPAC system only. Please do it, pause it, and come out of that. 5 minutes max. And then after 5 minutes, award 1 mark for each correct and 0 for each incorrect. 5 minutes, pause. See, I have written all the answers. Let's see how much marks you have obtained. Right? I have solved all on the next page. Right? All here with. Please see to that how many marks you have scored. Answer to yourself. So if you're scoring maybe more than 60% marks here, I'm a happy man. ठीक है जी? अरे, what is this? Which of the following is aromatic alcohol? I have taken this question from somewhere. It has been asked in some competitive exam. Aromatic alcohol. What's your answer? Pause. 1 minute. Pause. Your answer is C. B and C are aromatic. A for aromatic. A for aromatic alcohols. Award +4 for correct, -1 for incorrect, and 0 for if you have not attempted. unattended. Right? Please proceed ahead. This is a test for you. Right? 4 questions. Please pause it, solve it. 3 minutes. Pause. That's the answer. Okay, बच्चे, kindly award yourself marks. So this is total marks is 16. How much you have scored? Right? 1 question and 3 questions. 4 questions. So 4 into 4 is going to be 16. How much you have scored today? That has to be seen. Right, my dear friends? तो आगे चलते हैं and let's take you to the MOP. I hope you have watched the previous session also. So MOP goes for methods of preparation for alcohol. Extremely interesting, rewarding, and the best thing is as you move ahead in every chapter of organic chemistry, last topic becomes even more and more interesting and understandable. Shall we move ahead? Methods of preparation of alcohols, phenols, aromatic alcohols. I will discuss all the methods of preparation in the sequence of your chapters taken from your class 11th and 12th, right? NCRT or ICSE. First, you discuss alkanes in class 11, then alkenes, then alkynes, then benzene, then halogen derivatives. So we move in a similar way so that in your exam, you have a fairly good estimate that how you can convert one into another. This method of preparation you have discussed in class 11th also. This method of preparation says when alkanes are heated in the presence of copper tubes or iron tubes, you just pass alkanes, which are normally gases. In the presence of air, air will give oxygen. Copper tubes or iron tube act as a catalyst. You generate alcohol. For example, methane, which is very much abundant from the natural resources. Even gobar gas, you might have heard that nowadays we are processing even more and more that contains methane. So you can produce methane from animal refuse, maybe the sewage industry, right? So methane, when passed through copper or iron tubes and heated, triangle goes for heat. This is a symbol for heat in chemistry. You're going to generate methanol. This is a very important method and it is a very cheap method of producing methanol, right? Alkanes are hard to oxidize. Alkanes are very stable. But remember, alkanes having 3-degree hydrogen. Remember, only 3-degree hydrogen are oxidized to OH by KMnO4 or dichromate. I repeat, only 3 degree. This carbon is 3 degree. This is known as isobutane in the common language. Isobutane, common language, parenthesis. This is going to give you tertiary butanol. Only 3-degree carbon is going to be oxidized. That means if you are having some species like this, O for oxidation, KMnO4 or dichromate, there will be NR matlab no reaction because it does not have any 3-degree hydrogen. That's important, my dear friends. Only 3 degree. What are we discussing? We are discussing methods of preparation of alkenes, alcohols from alkanes. First thing. What comes in your organic chemistry after alkanes? This is from alkenes. MOP. First, from alkanes. Second, from alkenes to be discussed. This is, I'm not writing very important. This is extremely important, my dear friends. Not very, extremely important. Please be attentive, right? Be attentive. Alkenes, I will discuss in details. Right now, I'm introducing, can be converted into alcohols in many varieties. Of those, three more important, or you can say very, very important, are being discussed on the screen. First is known as acid catalyzed hydrolysis. Acid catalyzed hydrolysis. ACH, acid catalyzed hydrolysis. What is that? You add water in the presence of little bit of few drops of HCl or sulfuric acid. So here, the more the carbon atom having lesser number of hydrogen atom is going to get OH, that is known as beta Markovnikov addition. You remember Markovnikov addition? The negative part of the adding species will go on the carbon atom which is having lesser number of hydrogen atom. The second method is known as oxymercuration demercuration. I will discuss what do we add, how it happens, and that gets the same product as the acid catalyzed hydration. That is Markovnikov addition. The products are the same. You can choose any one of them depending upon your ease, your availability of resources. The third one is hydroboration oxidation. We call it hydroboration oxidation. Gives you anti-Markovnikov addition. Notice the third wala. The OH has gone on this carbon. And that is the beauty of hydroboration oxidation, that we get some product which is not going to be otherwise possible. So just revision, stressing because of importance. We are just going to discuss one by one all of these. Acid catalyzed hydration, go slow. Oxymercuration, demercuration, close your eyes, gives Markovnikov addition, right? And hydroboration oxidation anti-Markovnikov addition हमें देता है, right? करके देखते हैं बेटे. This is the way we should remember, है ना? Say we have this. You do acid catalyzed hydrolysis, first वाला abbreviation use कर रहे हैं, or you use oxy demercuration. Please, I'm using the abbreviations. You are going to get OH here. That is going to be the Markovnikov addition. Markovnikov addition. This carbon is having no hydrogen. Now I'm changing the color. If you use hydroboration oxidation, different books will use hydroboration oxidation. I use, for the sake of simplicity, HBOAM. AM goes for anti-Markovnikov. In that way, we will remember. We will have the OH here. Here it is CH. That is the anti-Markovnikov addition is obtained. Do you understand, my dear friends? That is what is happening, how it is happening better. See, I said we will discuss one by one. Acid catalyzed hydration. Acid catalyzed hydration. In acid catalyzed hydration, the first thing is you should understand the reaction, right? Markovnikov addition, ये अभी बताता हूँ. The rearrangement is possible. Rearrangement is possible. I just discuss in coming screens. The carbon atom which has less hydrogen atom will be getting OH. Here we get OH. You can remember OH negative and H positive. You can put it in your mind, right? So that is going to be the Markovnikov addition, acid catalyzed. How it happens? The mechanism, how it happens. What are we discussing, my dear friends? Acid catalyzed hydrolysis. See, alkene, I'm here, focus here. Alkenes are going to react with electrophile. They are electron rich, and that is H plus, the catalyst is going to provide. Now, this is going to shift electron in this way. The first carbon has lost its electron to hydrogen atom. Okay, no problem. I show it the other way, the way the slide is showing, right? The first carbon has lost its electron present in the double bond to hydrogen, resulting into a carbocation. A carbocation. Now, a carbocation, just remember, carbocation is prone to rearrangement. They can rearrange from 1 degree to 2 degree or 2 degree to 3 degree depending upon the circumstances by shifting either hydride or methyl from the neighboring carbon atom, because that will lead to more stable carbocation. Right now you have added water also. Water is going to attack on the carbon which is electrophilic because it is electron rich, and we get what? We get protonated alcohol. See, this is agar if only this is present, this is alcohol, but this is protonated alcohol. Now this alcohol loses H plus, resulting into a alcohol, right? So what happened in three steps? What happened in three steps? First step is attack of electrophile to form carbocation. To form carbocation, right, bachcho? Second step is the attack of nucleophile, that is the water attack. And my dear friends, just a minute. The third step, I'm just making a contrast. The third step is deprotonation, loss of H plus to form alcohol. How many steps? Three steps. Please copy it. That's going to be good for our health. I said the carbocations rearrange. Carbocations rearrange. So why don't you try it first, right? Try it first. Pause the product of this. Pause it for you should not take more than 3 minutes. Then just resume the play and go to the next screen and watch what has happened. Pause it. I'm going to the next screen. See, my dear friends, the H plus will attack. You remember first step, attack of this. I'm only writing the major product. C, CH3. I'm not writing the 1 degree, you know it. Now, this is a carbocation. 1, 2 hydride shift, because that will result into a 3 degree carbocation. Now, bete, it is attack of water happening. You can simply show it like this. No need of showing it in a spread way, the way I did. Now, minus proton. Wait, sorry, that is CH2 is the actual product. If you do not know the rearrangement, so you would have said which is not going to be formed. The red one, the red process has happened because of, my dear friends, what? The hydride shift. So that is what I'm saying. The shifting is possible. The hydride shift will happen. What are we discussing, my dear friends? We are discussing methods of preparation. First, we have discussed, right? And here I have discussed that rearrangements possible. Right, बच्चों? आगे जा सकते हैं. The rearrangements are possible. Let's move ahead. Let's go to even important oxymercuration, demercuration. Oxymercuration, demercuration. This is very, very important, and mechanism has been included in your school syllabus also. Oxymercuration, demercuration. Alkenes react with mercuric acetate. Write down the name, mercuric acetate. Here, mercury is the positive part, and this acetate is the negative part. In water and tetrahydrofuran is the solvent, right? Tetrahydrofuran, this is THF, tetrahydrofuran. Water and THF mixture to form hydroxymercuryl adduct. Say, I'm writing first step, same product, same reactant, alkene, mercuric acetate, THF and water. You get Marconic of addition only, CH and OH, and on one side you have HgOAc. HgOAc. This hydroxymercuryl adduct on reduction, oxymercuration, demercuration, on reduction with the sodium borohydride in basic medium. Kindly remember, this is the second step. Give Marconic of product. This is going to be removed and the OH is going to be present here. The OH is going to be present here. Remember, the important distinction between the two is no rearrangement is going to happen. No rearrangement is going to happen. See, the propene, the propene. You can write simply in this way, bacho. That is okay. Perfectly okay. First step, mercuric acetate, and second step, sodium borohydride in the basic medium. You get this thing. First step is mercuric acetate. Mercuric acetate, right here, is going to lose CH3CO negative, and you will be left with OAC, right? AC goes for CH3CO. This is the electrophile now. It will form a cyclic carbocation. There H plus has added, here HgOAc plus is going to add. This cyclic intermediate, it's a carbocation, cannot rearrange. I stress bit, acid catalyzed hydrolysis mein H plus has added. It form a carbocation according to Marconic of addition. Here HgOAc positive has been added. It will form Marconic of addition, but it does not have enough energy to rearrange. When you add water, notice this is going to be OH2, positive protonated, and HgOAc goes here, right? This is water attack here. Now the H plus is going to be removed. And lastly, you're going to do sodium borohydride reduction in basic medium. You're going to get the Markovnikov product. The Markovnikov product. The cyclic intermediate show Markovnikov addition of water, that is, right, attack of water, Markovnikov addition of water, that is attack of nucleophile, will happen where carbocation is more stable, that is Markovnikov addition, but it does not have enough energy to rearrange. Do you understand what has happened, how it has happened? Take a minute, my dear friends. Yeah, I'm just going to bring it here. Just a minute. Here. See, with a few minutes earlier, let's discuss it. The blue pen. If you do acid catalyzed hydrolysis, we get Markovnikov addition plus rearrangement, right? And if you do oxymercuration, demercuration, you get Markovnikov addition and no rearrangement. That's what I'm discussing with you again and again, my dear friends. Do you understand what is happening and how we are moving ahead? Now, I'm going to take you towards the third, the hydroboration oxidation. I will call it HBOAM, anti-Markovnikov addition की वजह से. Remember, borane. It is boron is the positive part and hydrogen is the negative part. First thing. And diborane always dimerize to form. Boron BH3 does not exist alone. It exists as B2S6. And a word of caution, diboron is a highly toxic gas. It is also used as a rocket fuel. It's a producer of hydrogen under certain reaction. Your choice, you can simply remember in this way, right? You can simply remember this way. First product diborane, second step is oxidation and basic medium H2O2 OH negative. Anti-Markovnikov addition. And mechanism, you add BH3, it will form B plus 3 and 3H negative. You know H negative, the negative part will go here. You will get CH3, CH2, CH2, thrice boron, trialkyl boron. That on being oxidation forms anti-Markovnikov alcohol. What I have discussed with you, notice this is I have discussed. The first one is Markovnikov addition, rearrangement हुआ, acid catalyzed hydration. Oxymercuration, demercuration, Markovnikov addition, no rearrangement. Please notice the difference between the two. And diborane, hydroboration oxidation, is going to give you entirely different product, anti-Markovnikov addition. Copy it in rough. And you know, I said that do not copy the nomenclature. But now what you should do is you should stop, right? Pause, and you should make notes. In your mind, you have to revise alkenes can be converted into alkanes in 3 ways. Right, beta? One more thing. I cannot help you here, my son. Why? Because this is as such. But I advise you that you should remember OXO process. Why? Because in boards, they have asked, write a short note on OXO process. So this is 100% rote learning, no understanding. It's just practice. Why I'm asking you to memorize? Because this is an important industrial process for preparation of alcohols. Ethene reacts with carbon monoxide and hydrogen in the presence of cobalt carbonide. CO, CO4 twice. This is dicobalt octacarbonyl भी बोल देते हैं. As a catalyst at high temperature and pressure to give aldehydes. Till here it is aldehyde. The catalytic hydrogenation means hydrogen nickel, hydrogen platinum gives primary alcohols is going to be obtained. That is the another method of preparation for alkenes to alcohols. So how do you remember? You remember in this way that we discussed method of preparation of alcohols from alkanes apart from nomenclature. The copper tubes, iron tubes, high temperature, methane is going to give you methanol. Kindly revise mentally the methanol. From alkenes, we discussed three methods. The more number of times you revise, the more comfortable you are going to be. Acid catalyzed hydrolysis, oxymercuration, demercuration, hydroboration, demercuration. Please remember the three methods. Now copy it, scribble it somewhere. We also discussed one more method of preparation, alkenes to alcohols by the OXO process. OXO process में first you added carbon monoxide and hydrogen in the presence of octacarbonyl cobalt, then hydrogen nickel. This is beta what we have discussed today. So till now we have discussed this only. Next session we will proceed that how will we prepare the halogen derivative to alcohols. We have discussed it already in halogen derivative, so that is definitely going to increase our speed. Okay, so Jai Hind and see you again with method of preparation for alcones. Continue to next class. Bye बच्चों, God bless you. खुश रहो. See you again. Bye. Bye bye.